Okay, welcome back to 345 Delta Foxtrot. This is part 2 of drilling, deburring, and countersinking holes. And today we're in the shop, also known as my garage. And the plan is to do something fairly simple. We're going to drill 5 holes and deburr them and countersink them, which sounds like it shouldn't take very long, but we're going to try and do things carefully and learn a few things on the way. But we're going to have to move along so that this video doesn't end up being too long. So this is my drill press. It's a win. If you want to know more about it, you should have watched part 1. So the first thing to do is to check the setup. Okay, drill speed is set here. We're going to be drilling aluminum, so we want it on the fastest setting. Largest wheel here, smallest wheel here. Check the belt tension. It's not real critical. You don't want to just crank it down as hard as you can and get it as tight as possible. It doesn't have to be all that tight, but you don't want it flopping around either. So that should be just fine the way it is. Okay, now we're going to take a transfer punch and, oops, wrong way. Oops. There we go. And here we go. Here's a square. And we're going to check it real quick for square. I'm going to have to, let's just try going this way. I don't know how well you can see that in the camera, but it is pretty square. This is something you shouldn't have to adjust very often, but the stage does tilt, rotates back and forth that way if you loosen the nut back here. So once you have it set up, it should be okay. Okay, there's one other thing you can do. It's kind of a marginal item, is you can take a dial gauge and you can place it on your transfer punch here, or you would actually like to be using something very high quality, known round, and you can measure the run out. And that just means that as you turn the transfer punch, or the whatever you have chucked up here, the dial reading should not change at all. And of course it is going to change a little bit by a couple of thousandths. But I'm not going to do that. Part of the reason is there's not much I can do about it if it comes out not particularly good. I've checked it before and it seemed to be basically okay. Basically what you'd probably do if it was really bad is to replace the chuck. And a new chuck, fairly good high quality chuck, would probably cost as much as this whole drill press did. So like I said, checking the run out is kind of a marginal thing to do. Okay, so the plan is to match drill 5 holes, 1 inch apart. I've already got them marked here. This is a piece of Vance's skin. It's 2024 aluminum, and it's 16 thousandths thick. This is just a bar of aluminum from Home Depot. It's 1/8 of an inch thick, and it's 3/4 inch wide. And I cut this to be 3/4 inch wide. So the first hole, well, the first thing to do is to center punch the holes. And I'm not going to spend much time on these because it's not critical for what we're doing here. Okay, the first drill bit we're going to use is a Cleveland Aircraft Tools drill bit. It's the number 40. It's the one that you would normally use. We need to adjust the height of the stage a little bit. I recommend that you adjust the height of the stage before you check up your drill bit, because oftentimes you can jam the stage into the drill bit, which is not good for the drill bit. And I'm going to be a little bit sloppy. I'm not going to clamp this stuff down. This is just aluminum. It's pretty soft. I'm just going to clamp it with my hands. And I've done this before, so I'm not expecting any sort of problem. So just turn it on and drill the hole. Okay, now, like I said, we're going to be match drilling here, so just take a cleco and cleco it together in the first hole. And for hole number 5, I want to use a different bit. I want to use the Harbor Freight high-speed steel bit. This one is not a number. This next one is not a number 40. It is it's a 3/32. Okay, take another Cleco. Okay, 3/32 is a little bit smaller than a number 40. That's why the Cleco had a little trouble going in. So that's to be expected. Okay, the center hole is, we're going to use, this is my full set of Cobalt bits from Harbor Freight, and this is a number 41. So it's one size smaller than our first hole, which was the Cleveland Aircraft Tool number 40. Okay, I don't, okay. Okay, that's not going to work. We're going to need okay. Okay, we're going to drill hole number 2. Okay, this is the same as the first hole. They're both number 40s. The first drill bit was Cleveland Aircraft Tool number 40. And this one is out of my Harbor Freight set, and it's also a number 40. Okay, this is also a Harbor Freight bit, Cobalt, and it's 3/32. So this is going to be hole number 4. Oops. Okay. Now let's, we can see how they all came out. Oops. Okay, I'm going to switch to the close-up camera here. So those are the holes that we just drilled. Number 1 is Cleveland Aircraft Tools number 40. Number 2 is Harbor Freight number 40. Number 3 is Harbor Freight number 41. Number 4 is Harbor Freight number 3/32. And number 5 was the 3/32 high-speed steel from Harbor Freight. So the top surface typically comes out pretty good. Not much of a burr. Before I forget about it, let me identify these. And let me mark both sides. And let me mark both sides of this as well. And I'll mark this as back. Oh. Okay, let me try and focus that a little bit. It's about as well as I can focus it. So like I said, typically the front side comes out pretty good. There's 2, 3, there's 4, there's 5. And we might see more of a burr on the back side. These actually don't look too bad. It's probably because they were up against this other piece of aluminum. So that's 2, 3, 4, and that's 5. hold it. Let me repeat that. I may have gotten that backwards. This is the back. Yes, I think you can see a little bit more of a burr on these. So this is number 1, number 2, 3, 4, and 5. Okay, this is the front of the 1/8" thick bar, and pretty good. Pretty good. Number 3, number 4, number 5. Now this is probably where we'll see the biggest burrs. Yes, you can definitely see a little burr there on number 1. Not too much on number 2. Number 3 definitely has a fairly good burr on it. Number 4 and number 5 definitely has a burr on it. Okay, so now what we're going to do is we're going to run the reamer through the holes, and it should clean them up significantly. Okay, let me switch back to the other camera. Okay, I have the, oh, actually I don't. Okay, this is the Nova palm drill. And if you remember from part 1, this is the one that I mentioned sometimes doesn't get the respect that it deserves. And I disconnected the air before I added the reamer bit here. And it is very easy to accidentally push the start button when you're changing bits, because this is so small and compact. So definitely your safety tip is always disconnect the air before you do anything with this drill. Okay, reconnect the air. Oh, you can hear the air compressor come on. Okay. Okay, that should have cleaned things up a little bit. Let's go back to the close-up camera. Okay, this is definitely the front. Number 1, number 2, number 3, number 4, and number 5. Everything looks pretty good, feels pretty good. Okay. Number 1, pretty good. Number 2, pretty good. Number 3, pretty good. Number 4, pretty good. And number 5. They're all pretty clean now. This is the 1/8" bar. Number 1, 2, 3, 4. Let me feel number 5 there. Number 5 still has a small burr. Okay, this is the back side of the big bar. There is a little bit of burr still left on number 1. 2 looks pretty clean. There's definitely some burr left on number 3. Number 4 looks pretty clean. And definitely some burr on number 5. So the worst burr is on number 5 and number 3. So number 5 was the 3/32 high-speed steel from Harbor Freight. And number 3 was the number 41 drill bit, Cobalt Drill Bit from Harbor Freight. Wasn't really expecting that. I was expecting number 3 to look pretty good. Since it was undersized hole and then reamed. But it's not looking all that great. So what we want to do is we want to deburr the holes. And this is just a cordless drill. Oops, sorry. Go back to... this is just a cordless drill. And it has the Cleveland Aircraft Tools deburring tool in it. And so these are already pretty clean, but I'll just quickly run the deburring tool through them. Okay. Those feel good. Yes, both sides, nice and smooth, no problem. Okay, this is the front side of the bigger bar, and it should be pretty clean already. And it's going to get countersinked, so it's not going to really matter. Okay, this is the back of the big bar, and I'm going to countersink the crap out of, or deburr the crap out of these holes here, because I want this bar to sit very nice and flat. We're going to try and make some measurements in a minute here, and I want to make sure the bar sits very flat and has nothing sticking out the back. And in this particular case, it doesn't matter. Okay. Feels pretty, oop, number 5 still has a small burr on it. Okay, that's better. And the front side is good. Okay. So, what we want to do is we want to dimple this piece, and we want to countersink this piece. The camera is pointed in the wrong direction for you to see me dimple these, but it's very simple and very quick, and I'm just going to go do it off camera here in real time. Okay, there's number 1, number 2, number 3, number 4, and number 5. Okay, that's the top side, and then there's the dimples from the bottom side. Okay, time for some countersinking. Okay, this is my countersink tool. This is the cage, and the bit is right there, and it's already set up. So what I recommend that you do is get it set up reasonably close. Doesn't have to be exact. And then put a mark on it. Okay, the way you adjust it is there's teeth, and you can turn it by one tooth mark, or one tooth, and that's 1/1000th of an inch. Okay, and in this particular case, I turned it so that the hole that it drills will be shallower. And then that's back to my mark. I'll try and show you this on the close-up camera, but I don't know if it's going to come out because it's a black mark on a black tool. I don't think the camera is going to pick it up. You can kind of see it there. Okay, the mark is right there. So the question is, how do you get it close? I've spent a lot of time on that, but here's some test holes that I countersunk. And I put a rivet in one of these holes. And that's basically about what it should look like. You should see just a nice, small, shiny ring around the edge of the rivet there. And then you'll know you're close. Okay? If you see no ring at all, you're flush or even above flush. And if you see much more of a ring than that, you're too deep. And your eye is actually quite good at judging. Once you've seen a few of these, just by looking, you can tell about to within a few thousandths of how deep the hole is. Okay. There we go. So okay, I've done a fair number of experiments to try and find out the best way to countersink. And my recommended method is what you do is you start off by countersinking all the holes, not enough, not deep enough. So I'm going to take it from my mark, and I'm going to go 1, 2, 3, 4, 5. I'm going to go 6 thousandths too shallow. Okay. And then you can tighten it down like that. And oops. Just the height of the stage, so it's about right. Okay, since we know that these holes are not going to be deep enough, these countersink holes, we can go pretty quickly. We don't have to, just zip right through them. Okay, let me show you another little tip. As you might be able to see in the camera, I'm not sure. When you start up the drill, the cage rotates, and it's kind of hard to see what you're doing. And then you start the countersink, and it quits rotating, and there's a pretty good chance it'll stop rotating there and not there. If it stops rotating there, then you can still see what you're doing. But if it stops there, you can't see what you're doing anymore. So let's see. All you have to do is, we'll just use this tape. Just take a piece of tape, and we want to go pretty long piece of tape. We want to be able to see, well, it's going to interfere with resetting the countersink, but we'll just have to reset it. Okay, that will keep the cage from rotating now. And so to make it a little easier to see what's going on. Okay. Now we've got them, step one, partially countersunk. So now what we want to do is come back and do them precisely at the correct depth. So we want to clean everything up a little bit. Okay, when I put the tape on here, I covered up my mark. So I'll just have to redo it. Okay, oops. Okay. It helps to, not a lot, but a little bit, to add a little lubricant. This is Bow Lube. I talked about this in part one. And you can just take a little bit of this and run it across so that there's just a tad, a little bit in each hole. You don't need much. And it doesn't have to be distributed nicely or anything. The countersink will smooth it out. Let me grab a paper towel. Okay, so this is time to do our precision countersinking now. And get it all cleaned up, your whatever you're countersinking, nice and flat, and we've got the Bow Lube, and try and apply the same force each time. Do it as consistently as you can. Okay. So we need to find out how they came out. All right, I need to switch back to the other camera. Okay, I think that's as good as I can focus it. So this is the setup. So we have a dial gauge here. This is a magnetic mount. These are all described in part one. The magnetic mount is on the steel plate, which is the back riveting plate that comes with the Cleveland Aircraft Tools RV10 toolkit. So you just need a nice piece of steel so that the base to clamp to and hold everything steady. You need to do this over a hole, and you want a nice, clean, smooth hole so that the bar that you're going to measure is sitting nice and flat. And okay, so you just raise the dial indicator up, put the bar underneath, and the rivet is sticking out the back side. So unless you have a very thick piece of aluminum, the rivet is going to stick out, and that's why you have to do it over the hole. Okay, so right now we are measuring the top of the bar, and it is measuring right at 47. Okay, I'm going to move over to the rivet, and it is it's about 40 and a half. Let me get a pen. And we'll write this down. 47 minus 40.5 is equal to 6.5. Okay. We move the rivet to hole number 2. Okay, we're right at 49 here. Okay, we'll call that 49. And, oops, I want to go into the dimple. Right about there, 42 and a half. So 49 minus 42.5 is 7.5. Okay, this is number 3. And right now that's right at 49. And that is right at 43. So 49 minus 43 is 6.0. Okay, this is number 4, and we're right at 48. And wow, that's 38. For some reason, this one seems to be off. Let me try that again. Okay, yes, we're right at 48. And we're right at 38. Okay. Okay, the last one. Okay, we're right at about 47, maybe 46 and a half. Okay, it's 36 and a half, and that was 46 and a half. That's 10 again. Well, we were doing pretty well. 6 and a half, 7 and a half, and 6, and then we got 2 10s. And it is just difficult to do any better than that. And part of it could be the measurement, but I don't think so. Say we go back and measure number 4 here. Okay, that is right at 48. Oops. And now it's right at 38. So it's still reading about 10. So, like I said, that's just the way it is. If you can find a better way to countersink and do it more consistently, please leave a comment. But this is the most consistent way that I've been able to find so far. Now, there is one other way to do the measurements, but I don't think it's as accurate. Okay. Let me move this out of the way. And that is using a digital caliper. Again, this is in part 1, the one I have. It's this NACO brand. Okay, so what you do is you turn it on, you zero, you close it up. It's already reading 0, it's already zeroed. So we're okay there. Okay, Now, you bring it out a little bit so that this little bar sticks out. Then you're going to use that little bar to measure the depth of the rivet. And this is going to be hard to do without my blocking the camera. Okay, you want to bring it right straight down on the rivet there, and as flush and as best you can, and it's a little tricky. Okay, I got 12.5 thousandths. Let me try it again. Let's see how consistently I can do it. Okay, that time I got 11 thousandths. So using a digital caliper, your measurement error is probably a couple of thousandths. Maybe if you practice and you have a super good digital caliper, you can do a little better. But I found that the dial gauge gives the best and most consistent results. Okay, so that's pretty much what I wanted to do in this video. There is one additional thing we can do fairly quickly, I hope. And that is, we can take these two pieces. The top one we dimpled. Oh, it's got the rivet in it. And they fit together pretty much like they should. But it's very difficult to look at it from the side and tell if it's going to be flush completely or it's sticking up a little bit or whatever. One little additional step we can do fairly quick is we can go ahead and rivet these together and see what they look like after they're riveted. Okay, this is my squeezer. It's the Harbor Freight Tools squeezer, which is very nice. It's adjustable just by turning this bottom piece here. I'm not going to talk about the squeezer right now. I think this video is going to be long enough. These are AN 426 AD 3-4.5s. Oops, let's see. How do I want to do this? That's pretty good. Close enough. Probably should have put some Clecos in this. Yeah, I think just holding it is good enough. Okay. Seems pretty good. Let me go back to the close-up camera here so you can see a little better. Okay, that's what they look like from the top. Not too much to see. And seems pretty flush to me. Looks like there could be a slight gap on that second one. Let's see, try moving that piece of paper a little bit. So, okay, I think I can just barely see a little bit of a gap there. And that one seems pushed up a little bit, but I don't see any sort of gap. So it's hard to say. And I mean, it's bent up on the end there, but that's doesn't have anything to do with it, anything. So I would say that 7,000ths number seems okay. I don't know if there's some way to do things a little bit better or not. I haven't been able to find any way to do anything any better. Okay, I think that's it for this video. This one is a little bit different than my previous videos, which were PowerPoint videos. Feel free to leave a comment about what you like, what you prefer. So if you want to recommend these videos to other people, the thing to do is to subscribe, give it a thumbs up, or leave a comment, and that will tell the YouTube algorithm to recommend these videos to other people. And I guess that's it for now.